Alright, this is lesson 9.3. It's on compound events. We've been dealing with simple probability, meaning one thing. For example, simple probability of flipping a heads is 1 out of 2. Simple probability of rolling a 4 on this would be 1 out of 6. The simple probability of getting a red out of this would be 3 out of 7. The simple probability of getting either or, remember either or, we add the probabilities together, of getting fish or cat would be 2 out of 5. So those are what we call simple probabilities. There's only one thing happening. Even though it says either or, I'm only spinning once, and I win if I get cat, and I win if I get fish, either one. All right. Now we're going to go on to compound probability, which means compound probability is when you have 2 or more simple events, and both of them have to happen. I always use the example, if you come home and your mom says you can either take out the trash or clean out the garage, you're going to choose the easy one to take out the trash. That means you have 2 ways of winning, like we talked about earlier. But if she says you have to take out the trash and then clean out the garage, both of them have to happen, and that becomes more difficult to make her happy, right? So, for example, we'll do a compound one. I'll just use these two. We'll do a spin and a flip. Okay, so what is the probability that I get cat and then I get tails? Okay, I should put the word the and or and then. That way we're realizing that both things have to happen. Well, to do compound probability, all you have to do is figure the probability of the first. There's 1 way out of 5, so probability of getting cat is 1 out of 5. Probability of flipping tails is 1 out of 2. Probability of getting them both done is multiply those two together, and you only have a 1 out of 10 chance of getting both of them done. So to find compound probabilities, all you have to do is multiply each individual simple probability. I'm also going to make for you an organized list. So you could get, if I made the organized list of all those, you could get cat heads, you could get fish heads, you could get pickle heads, you could get car heads, you can get candy heads, or you can get all those same things, cat but tails, fish but tails, pickle but tails, car but tails, and candy but tails. And remember what we were wanting to get, is we wanted to get cat and tails. There's only one way to win out of 10 possible outcomes that we could get there. So you could figure out how many possible outcomes there were in a lot of things, basically by figuring out how many outcomes there are times the number of outcomes. So like if I did this, aren't there 7 outcomes? 1, 2, 3, 4, 5, 6, 7, and maybe I'm going to spin this. Aren't there 6 outcomes? 7 times 6, guess what? There's 42 possible outcomes, right? And if I said, what's the probability maybe that it's even and then green, we'll do that one. Even and then green. So I'm going to spin I'm going to roll the die. I get an even. Isn't that half of them? It's 3 out of 6. And then green, I have 2 out of 7. And then means both of them have to happen, so I'm ready to multiply. Or I can, of course, cross simplify. And my probability is going to be 1 out of 7. Means I really have 2 out of 14 ways to win, but we'll simplify that down to 1 out of 7. Unlikely. Okay? So to review, this either or is really not a compound thing because you're just doing one event, but you add the probabilities. But this is the compound part. We multiply the probability of the first times the probability of the second. So let's go try a couple. We're going to pick out of both boxes. So it's probability I get an X and then a soccer ball. Well, the probability I get an X, you can count them. I have 1, 2, 3, 4 X's. So that's 4 out of them. I count how many? 1, 2, 3, 4, 5, 6, 7. 4 out of 7. And then I count the soccer balls. 1, 2, and 3. Out of, count them, 1, 2, 3, 4, 5, 6, and 7. So 3 out of 7. If both of them have to happen, 4 sevenths times 3 sevenths, I don't know why I wrote 3 there, is 12 49ths. 12 49ths. Not likely, right? Unlikely. Okay, let's try another one. What's the probability I get either X or O and then football? All right, remember this first one, Either X or O is really just one simple event, but I have more ways to win it. So the probability of getting X, again, was 4 out of 7. Probability of getting O is 2 out of 7. So if I add those together, because either or means add, I get 6/7 chance of getting that done. And then I have to multiply. Probability of getting football, I have 2 out of 7. So now I would have 12 out of 49. Okay? Compound probability takes probability of the first times probability of the second. I do want to mention one, so I'm going to do this one time. We'll take one of these and unlock it. All right. For future, we need to be careful about replacement. If I said probability soccer ball and then soccer ball, you'd have to be careful because I'd have to know, since I'm drawing out of the same box, do I put it back in or not? Because if I drew out of the same box, right now I have a 3 out of 7 chance of getting a soccer ball. If I take it out, notice I no longer have 3 soccer balls, I don't have 7 soccer balls. So if I put it back in, we'll call that with replacement. So with replacement, this wouldn't change and I'd still have 3/7 chance. When I multiply them, I get 9/49. If I say without replacement, you'd start out the same way, 3/7. But then when you draw a soccer ball, when you draw a soccer ball and don't put it back in, that changes the probability. And now I only have 2, and there's only 6 in the box, so now I have a 2/6 chance, which I can, of course, simplify to 1/3. Then I can cross-simplify to 1 and 1, and now it becomes 1/7. You notice these probabilities are not the same because we changed the probability. These are called what we call dependent events. The probability of the second thing depends on what happened on the first thing. All right, last thing I want to do here, actually, you got to be kidding. All right, sometimes it's difficult to find out how many are in the sample space, or you just actually need to see the sample space. So one way to do or get the sample space is to use a tree diagram. So I'm making decisions. I'm going to pick a soda out of those 4 possibilities, an ice option out of these 2, and a size out of these 3. And a tree diagram kind of looks like this. Is each time you make a decision, you're just going to kind of put a branch down for all these things. So I might get Mountain Dew, which I'll just call M, or Dr. Pepper, which I'll just call D, Coke, which I'll call C, and Pepsi, which I'll call P. Then I'm going to pick an ice option. Either I get no ice or I get ice on each one. Again, I'm putting down branches for each decision. And then I'm making a decision on each one of these. Should I get the small, the medium, or the large? And in order to save a little bit of time, we'll just do it this way. Small, medium, large for each one of these possible options. Boy, it didn't seem to save a lot of time. And now, just understand that when you have, like, let's say that L right there, it doesn't just represent an L. That L is connected to this D, which is connected to this N right here as well. So that is a Dr. Pepper with no ice in large. And now you can see that each one of these at the bottom would represent a possible drink order. So if you wanted to count them up, you could count them all up. Now there's a quick way that we're going to learn about called the fundamental counting principle. Since you have 4 choices for the first thing, and 2 choices and 3 choices, if you want the total number in the sample space, you just multiply those. 4 times 2 is 8, times 3 is 24. If you count these little underlines on the bottom, there would be 24. But sometimes it's really nice to see them, so you might actually want to list them all out. This is a Mountain Dew with no ice, but small. This is a Mountain Dew with no ice in medium. This is a Mountain Dew with no ice in large. And you can list all those out. That's called a tree diagram, and sometimes it's really nice to be able to see all the possible options. So this would be another example. Sometimes instead of a tree diagram, you can make what is called an organized list. An organized list, like I would do alphabetical here. If you're drawing one from each bag, I would write all of mine that start with a C. So C, and then I would choose in alphabetical order A, then in alphabetical order P. Then I would go to C, A, T. Then I would change this one over to O, so it'd be C, O, P, and C, O, T. And those would be all of my options that start with a C. One of the reasons I like the organized list is because then when you switch over to the M, you're going to make this exact same list right here, but just starting with M. So MAP, MAT, MOP, MOT. And then you're making all that same list with the Q. QAP, QAT, QOP, QOT. Again, if you want to know how many were in the sample space, 1, 2, 3 times 2 times 2. So 3 times 2 is 6, times 2 is 12. There's going to be 12 in our total list. Okay? Then one thing that I'm going to ask you on the test is, like, let's say if you make a word, you win $60. Well, let's find out the probability of getting a word. We know there's 12 items, 12 in the sample space. Cap is a word, cat is a word, cop is a word, cod is a word, map is a word, mat is a word, mop is a word, and the rest of them are not words, right? So we have 1, 2, 3, 4, 5, 6, 7 ways to win out of 12. So if I played 12 times, I would expect to win 7 times, and I'd win $60 each time. If I multiply that, that'd be $420 in 12 plays. And if I wanted to find out what a person should have to pay, I would just divide those two, and 420 divided by 12 is $35. So $35 would be what we consider a fair price. If you played all day long and paid $35, you'd basically about break even. If you paid $30 and played all day, you'd end up making about $5 every time you play. And if you paid $40, you'd obviously be losing $5 every time you play. All right, so to review, we now have simple probability, which is easy to set up a fraction, right, with the total number in the sample space right here, and the ways that you can win right up here. That's your simple probability. If it's either or, you're going to add your other ways of winning. If it's and then, you're going to multiply your probabilities, and that's called a compound event, which is what we covered today.